You thought your job was done, you wrote clean code, it compiled, it even ran, and then, boom, a wild memory bug appeared. Now what? Well, in Rust, this kind of crash literally isn't allowed. Why, you ask? Because Rust has a special rule that prevents it all from happening. No, I'm not talking about garbage collection, I'm talking about ownership, one of Rust's core features. Unlike other programming languages that let you write dangerous code and only catch the errors at runtime, Rust won't even compile unless your code is memory safe. In Rust, every piece of data has one owner. When you assign it to another variable, the ownership moves. The original variable is no longer valid. That might feel strict, but it prevents bugs. So, picking up where we left off, here's our task. As you can see, we're calling task and task. Essentially, what that means is we're borrowing it, like when you let someone read your notes, but you definitely want those notes back. Now, let's make a new function, call it markDone, and as you can see, we're going to give it and mutable, which means we're borrowing the task. Now, Rust only lets one mutable borrow happen at a time. Why? Because it doesn't want multiple cooks in the kitchen burning your data. So that's why when you call mutable task, only one object is allowed to borrow it. Now let's integrate this into our task manager. We'll write a function to mark a task as done using mutable borrowing, and because of ownership rules, we know our program is safe before we even run it. Now, before we wrap, here's a sneak peek at what else ownership controls. How values are passed around. Integers like x get copied automatically, but strings, well, they get moved, which means the old variable becomes invalid. Want to duplicate it safely? Well, you say it clearly with .clone, like asking your friend, hey, get me one too. Now, let's take this even further. Rust lets you borrow, but it sets some ground rules. You can only have one mutable reference at a time, or many immutable ones, but never both. The compiler becomes your safety net. It says, nope, not today, bug. And here's a fun one. Dangling references. Rust won't even let you return a reference to something that's going to disappear. It's like lending someone your coffee and then throwing it out before they sip. Rust likes nope, bad idea. Ownership isn't just a Rust thing. You're gonna be a better programmer thing. And hey, you just survived the scariest topic in Rust. Next up, lifetimes. They sound scary too, but I promise, we'll make them make sense. Now, hit that subscribe button.